The rocks of the Builth Inlier are middle to late Ordovician in age, around 465 to 455 million years old. At this time, Wales was part of the microcontinent Avalonia, which lay in the southern subtropics, with the Iapetus Ocean separating it from North America. The Builth Inlier preserves a complete history of a volcanic island complex, from its emergence to its erosion and disappearance. The whole process took around 10 million years and covers an area of around 50 square kilometres. The setting envisaged is that of a single caldera complex on the scale of Santorini. Some of the sedimentary sequences indicate a large, quiet water lagoon in the centre of the inlier. The story begins on an extensive mid to outer shelf region in the Didymograptus artis biozone in the Middle Ordovician. This thick sequence of siltstones and shales gets gradually coarser upwards and is interrupted near the top of the biozone by volcanic activity in the eastern part of the area. It is followed by a return to quiet water silt deposition. However, the quiescence didn't last long. Several episodes of volcanic tuff deposits are interspersed with argillaceous deposits. The water depth is very difficult to work out, but seems to have reached a maximum of 200 metres. Surrounding the inlier are much later rocks from the latter late Ordovician and, more extensively, the Silurian. The Silurian deposits mostly represent quiet, offshore shelf conditions with laminated grey siltstones full of graptolites.
You think it's Hornfels?
Well, I wonder if it could be a Hornfels tuff.
For that we need For that we would need an intrusion, of course. And there isn't one.
No.
Is the problem.
Yeah.
Because if there was, it would be obvious here.
Yeah.
As the dolomite always forms the high ground, and just the way it happens is quite distinctive. So
if it's not Hornfels,
that's good.
it's not baked.
Yeah. So let's have a quick look with the lens, and I can certainly see. Oh, there's flakes of quartz in there. Angular bits. Yep. Little bits of feldspar crystals. It's tough. That is quite definitively a bit of volcanic ash. So those were caught in the ash. That's just the way the rock moves. That's what the conchoidal fracture. Where is it? That bit there.
Yeah, well, you're not going to lose. That's your first sight of the graptolite. I feel sorry for you. That bit's much better. Forget that. Forget it.
The trouble is that you take a picture,
It doesn't do it justice.
No, I'm doing a plant. Right. I don't think it is pumpkin.
It's not
Foxgloves.
country related.
Foxglove, isn't it?
Yeah, they're all over.
Foxglove.
Yeah, loads of foxgloves around here.
Digitalis.
So, we are currently in the Builth Inlier. And you can recognise it because it's got Ordovician rocks, which tend to be hard and lumpy, and it's got intrusions, and there's nothing consistent about it. I mean, you're probably used to places where a formation might be a few hundred metres thick, and you can follow it for miles, hundreds of miles sometimes. It doesn't work like that around here. Quite often a formation is restricted to half a mile, and then it reaches out from 100 metres to nothing, and something else replaces it. That's just the thing with volcanic islands. So we're looking at an area where the landscape is affected dramatically by the rocks underneath it. So if you look in the far distance over there, you've got this big rounded massif. That's the Radnor Forest, which which is the highest point in the hill. It's over 2,000 feet, and it's basically late Silurian, mid to late Silurian mudstones. Pretty much homogeneous. It's just a massive array of thick layers of this sort of siltstone, mudstone, mainly siltstone, bits of limestone in it. Not much faulting, not much tectonics, and so you end up with this sort of huge, great rounded lumps. Go to the right, and you suddenly get this incredibly crenulated outline, the pointed heel with rocks on top of it. That's Llandegli rocks.
Oh, I see. What rocks?
Llandegli.
The one you were talking about last night.
Exactly, yeah.
The oldest volcanics.
So the area with the exceptional fossils is, you see the bright pink farmhouse to the right. Just up above left of that, you've got the bracken covered slope. At the top of that there's a scree slope, which is where that's where all the exceptional stuff is. And it's a long walk in from the road.
What about the bright pink farmhouse?
Bright pink farmhouse with buildings around it.
I'd say it's white with a orange.
Are we talking about to the left of the turbine?
Yes, you've got the turbines there. To the left of it you've got
Yeah. Okay, I've got you.
And then behind it on the left,
yeah. So just down from the first sort of rugged summit,
Yes.
there's a big scree slope about 2/3 of the way up.
Oh, that's scree, is it, rather than bracken or whatever?
Well, there is bracken there as well, but there's a big scree slope up there as well.
Okay, yeah.
But that's the Llandegli rock site.
Right, okay.
So that whole complex there is a series of volcanic layers with mudstone and ashes between them, but really thick, tough deposits forming the high ground. So you can see the edge of the inlier where you go from those rounded Silurian hills to Llandegli rocks. And the edge of the inlier is basically around there. But of course, between here and there, we've got soft, rounded, gentle sort of terrain, because that's all Silurian too. If you remember the shape of the inlier, try and do it reverse, it's sort of that shape. So Llandegli is sticking up at one end, and we're part of the bit that's sticking up at the west end, and it is an embayment which follows the boundary between the nice green fields and then the rugged highlands. So that's the edge of the inlier, which you can see going all the way around here. And once you've sort of picked it out, you can see it when you're driving around the area. It's just a different sort of rock. So down there is all Silurian. There are great big fault plains running along the edge of the inlier, which have moved a kilometre or so. So there's actually probably more than that. There's something like a kilometre of early Silurian. There's probably about the same of late Ordovician. So we've only moved at least 2 kilometres along the plain between here and there, vertically. So it's a lot of movement. But the high ground is, just as an aside, is where you find loads of standing stones, little hut circles, quarries and so on. And in fact we actually think that the raven, I think. Not quite sure. You do get ravens flying around here. That's not right. It's too small. It's a crow, yeah. But yeah, the scree site for Llandegli rocks we think is actually an ancient quarry site for when they were building a hill fort on the top of that hill. When we bumped into Scotland. Right, yeah. So at that point the entire Welsh basin was squeezed out of existence, and then you get the old red sandstone instead. But the entire area was shortened, so northwest, southeast, sort of gradient, the whole thing was squished by the collision, and you get faults all over the place. So some of those are large-scale strike slip faults, like the Church Stretton fault, which is a well-known one that goes to the Welsh borders, and there are lots of others parallel with that, and big fault structures like the Towy anticline and things like that, which runs through the whole of South Wales. But there's also a huge number of little faults which are just accommodating the main stress. And when you have an area mostly of mudstone with a huge great lump of granite sitting underneath it about 7 miles down, what you end up with is lots of accommodation around the granite. So we think the whole inlier is here simply because the granite formed an immovable object as the whole thing was trying to be sort of compressed. So you get breakage around the edges of it and the whole thing shifts. Yeah. So basically the inlier has come up relative to all of the surrounding rocks.
Is there a proven granite now?
Yeah, gravimetric surveys. It was already hypothesised from the spa waters, because one of them was lithium. And we also have radon problems in the cellars around here.
So is that from granite? That's from granites, isn't it?
Yeah. Lithium and radon, you basically they're very incompatible elements. So they basically go into the later stages of crystal formation within igneous rocks. So normally you get this in Cornwall, where you have these huge granite batholiths and the pegmatites concentrate things like lithium. So the last stages of crystallization. And so yes, just in the well, all the lithium and so on in these wells, it was pretty clear there must be granite there somewhere. But then there was a gravity survey done in 2002, Kieran Dollard, I think. Anyway, who found that there was this mass of lighter than expected rocks covering this large area around the edge of the inlier. So yeah, it's pretty certain. Nobody's dug down to find it yet.
I'll say there's no deep enough wells being drilled.
We're talking 7 miles down, 7 kilometres.
That's a
So it's a long way down.
hell of a long drill.
Yeah. Yeah, I'll take a picture.
Complete by any means, but it had a big bit of all three. It was the three main parts.
Well, without the spines, that means it's more, because
Yes.
nucleus shed their
More, yeah.
shed their front of the skeleton differently. And
Right.
they dropped off the lower lamella, which completes the spines.
Yeah. How long would the molting process probably take? Because it'd be very vulnerable.
Everyone's just finding stuff before I can actually tell you.
We'll listen.
Right. Attention, please. So this is the upper quarry, which is less famous than the other ones, but really shouldn't be. In fact, in paleontological circles, this quarry is now the one that people think about, since about 2011, when we finally published it. So those hydroids, by which we actually mean predatory sponges, of them here. There are soft-bodied worms and bits of arthropod and so on in this rock. And it's been overlooked for 50 or 60 years because it's so hard to spot the pyritite stuff. But the basic arrangement is dolerite at the end. That end wall you can see is clearly sort of igneous, and that's what's been quarried out. The underlying part of it is basically it's a tilted sill, so it's a sort of sheet of dolerite going that way. Underneath it is the mudstone, the upper layers of which have been hardened, they're baked. So you can see these hard layers at the top, which have been sort of sliding down just here. That's all baked stuff and is really good for graptolites, but not a lot else.
So do you mean it's metamorphic or going that way?
It's contact metamorphism.
Yeah.
But underneath it you have this really soft black shale, about 2 meters of it, which is extraordinarily rich in fossils if you get it unweathered. But normally, of course, it's weathered. And because it's triple SI, one needs quite sort of serious permission to be able to attack the outcrop for a very good reason. But there's normally loose blocks lying around which we can find some fossils in of the soft-bodied fauna. So this is the Conservat Lagstadt. I mean, it's listed in lists of Ordovician exceptional faunas around the world. It's normally on a sort of, if someone's publishing a summary of them, there'll be maybe 10 faunas from the Ordovician, and this is one of them. So it's a very, very special place. but it's also full of really spectacularly beautiful graptolites, which Lucy probably wants to say something about.
I think we can just let people explore them.
Oh, right, okay. And there are lots of sponges as well. You may get the odd bit of trilobite here, but it's a slightly different bed. This is slightly, we think, below the level that we're looking at in the other quarry, and slightly above the level in the main quarry. But it's sort of interval of slumps of black mudstone that just covered things, and probably alive in many cases. And you can get layers that are packed full of sponges. So you can see a sort of rusty weathering coming out from one level of over there. That's a layer of sponges. All the rust is the pyrite from the sponges that's oxidising and trickling down the surface of the cliffs. It's just completely covered in thousands of those cyatophytes. But yes, have a look around, and this is where you really get to test out your graptolite identification skills, because there's a lot more diversity here than there was in the other quarry.
Yes, and yeah, you'll find lots of graptolites. It is possible to narrow down the age using the really obvious ones, but you're going to have to look for the more subtle ones if you want to get the age exactly.
Yeah, there's one in particular which is a beautiful thing, and if you find that, you'll know it.
Yes.
So,
So,
off we go.
So we're at the end of the quarry, and we can see this huge blocky dolerite cell clambering up there. See some alteration on the surface of it, and then what appears to be underlying it and dipping to us is this black mudstone, which has been, it's very thinly bedded, just like slate really, but it's full of fossils, probably contact metamorphism. So I think this could be the underlying bed with the we look down the quarry face. I guess the dolerite has been removed. And there's a group checking out the remnants of the quarry for fossils. So what is noticeable in the scree here, you can see bits of rock with white surfaces. I'll focus in on this one here, and these are thin veins of calcite. You can see that one there, and there's another one there, and here you can see a thick vein of calcite in this rock here, which when broken up is seen there.